In our next example, we're going to look at a quadratic application through the lens of using our graphing calculator. Now, you can pause the video and read through this example. This is a setup for a track and field athlete who is throwing a shot put, and we are going to model the path of the shot put. Now, we are going to enter this into our graphing calculator, and I've already done so here. So you can see the the use of the graphing calculator, of course, and we have our negative in front, which tells us our parabola is going to open downward. We have our quadratic term, which tells us that it's going to be a parabola at all. And we're encouraged by this 6.1 over here as being a common sense starting height for the object. So when you throw a shot, you do not throw it from the ground. You throw it from at least maybe your height or a little bit higher, or even maybe a little bit lower. But regardless, you need that shot put to start off the ground. You should not have an intercept of 0. It doesn't make sense to have an intercept of 0. Now, unfortunately, the window for this is a little bit strange because you're not modeling time. You are modeling the horizontal distance traveled by the object and the vertical distance traveled by the object. And you don't really care how long it takes for the object to get anywhere. Your primary concern is making sure that you're looking at the distance traveled by the shot. Now, it's not clear that that's the horizontal distance, but that is the decidedly more interesting one than the vertical distance. But since we are looking for a distance and not time, we have to reconsider how we think about the x and the y. In this case, x is going to be a horizontal distance and y is going to be a vertical distance. Now, when we set our window, and I've already set the window, a window that I like, and you're welcome to experiment and see how the window looks for you, but this is the window that I set. We should expect a fairly significant horizontal distance traveled by the shot put and a fairly significant, but not as significant, vertical height traveled by the shot put as well. Now, you can use this window. You could see my graph and be like, I don't think that's a great window. I'm going to scale this down a little bit. But this is what the path of my shot put would look like. You're assuming that the shot put is being thrown from a height of 6.1. Here is the horizontal distance that it has traveled. And here is the vertical distance, the vertical height. I don't really want to say vertical distance because it doesn't land in the vertical. Shot put is measured in the horizontal. So we're looking at how far it ends up over here. Now, in terms of finding out that location, you might remember that the calculator has a few built-in functions to help us. We have our option of going second trace, entering the calculate menu, and choosing the zeros option. Now, you will have noticed that I left a little bit of room below the x-axis. The reason that I left that little bit of room is the calculator can be a little bit finicky when you try to move the cursor off the screen completely. So I left a little bit of room so that I can move it and still be on the screen, but be below the x-axis so that I can figure out where my 0 actually is. So we anticipate that this object will land at a horizontal distance of about 77 8/10 feet. If you're interested in the vertex, we can access that calculate menu one more time. We will be finding a maximum value. So we move our cursor to the left of the vertex. We move our cursor to the right of the vertex, and we make our guess, which as long as it's in that space, it should reveal the vertex with no problem. And there's our maximum. Now, the maximum is kind of finicky because the calculator uses approximation techniques, so it might spit out something like 34.999996, but really mean 35. So you need to take the graphing calculator with a little bit of a grain of salt, especially when you see answers with these long repeated decimals like this that are close to something familiar. If you're interested in particular values, maybe how long does it take for the shot to travel a distance of 10 feet in the vertical. So we can add in an extra line, y is equal to 10, and we can see those intersection points. We can trace over to those intersection points and get a rough approximation of how many times, or when is when is the shot put 10 feet in the vertical. This kind of analysis can be done. Obviously, is this better than using online technology that updates constantly and is a little bit more precise? Probably not. But in terms of the resources that are available to you, it's nice to use your graphing calculator and to know that those techniques are in there as well, especially those that will find those points exactly for you and you don't have to rely on tracing.